Right, so this question, like the one before, if you watched that video, is quite simple. So we have the mass of the puck, which is 1.75 kgs. So make sure you convert it into kilograms. You also have the initial height that the puck is being dropped at, which is 1.05 meters, and we do not know the gravitational potential energy. And so for question A, all it's asking is for you to find the gravitational potential energy. And in order to do so, we know this equation right here, and we're just going to plug everything in. All right, and once we do that, we get 1.8 joules. And now part B is asking that when the puck is initially in the air, and then once it reaches the bottom, what is the change in gravitational potential energy? Well, it's important to remember that at this point up here, it is all gravitational potential energy, and we will assume that once it reaches the ground over here, that it is all kinetic energy. And so up here, if it was 1.8 joules, then over here it should be 1.8 joules, but of kinetic energy. And up here was of potential energy, gravitational potential energy. So the change will simply just be minus 1.8 joules. Right, because we're basically converting all of this gravitational potential energy into kinetic energy. And so once it reaches the bottom over here, there will be 0 gravitational potential energy. Thus 1.8 minus 1.8 equals 0. So it's going to be minus 1.8 joules. And the last question, part C, is asking about work. And so this might be a little bit more confusing, but remember that the only work that is taking place is that of gravity, just causing the puck to fall to the ground. And so again, so that means in this case, because it's only gravity, work is equal to the gravitational potential energy. And we calculated that over here. So work is equal to 1.8 joules.